Before we begin, please press the like button and the subscribe button. Welcome everyone to this explainer. Today, we're unpacking a fascinating and honestly highly ironic situation in the cybersecurity world. We're looking at the recent Splunk vulnerability known as the Sidecar Breach. It is literally a textbook example of how even the most complex software can have some pretty massive hidden blind spots.
So what if the system protecting you actually becomes the gateway? That right there is the core question we have to ask ourselves today. It's the ultimate paradox of this digital heist. I mean, imagine installing a state-of-the-art alarm system on your house, right? Only to find out that the alarm system itself left a backdoor wide open for the burglars. In this scenario, a tool specifically designed to secure your digital assets and troubleshoot your operations is exactly what attackers are using to break in. Section 1, the Splunk Security Paradox. To really understand the mechanics of this attack, we first need to establish exactly what we're dealing with. Now, for those who might be newer to the platform, Splunk is an absolute powerhouse. Basically, it's a data analytics platform that gathers, catalogs, and analyzes machine-generated information in real time. It takes chaotic, unstructured system logs, literally mountains of data that would take a human lifetime to read, and turns them into actionable insights. It's the go-to tool businesses rely on to spot security threats and troubleshoot tech issues before everything crashes. And that is exactly what makes this exploit so shocking. Recently, the developers themselves discovered a severe vulnerability. It's officially tracked as CVE 2026-2025-3. But the defining characteristic here, unauthenticated code execution. Let that sink in for a second because that's a chilling reality. It means an attacker doesn't need to steal a password. They don't need to spoof an authorized user. No, they can execute malicious code on the Splunk platform entirely without credentials. No login required. Section 2, Anatomy of a Takeover. Okay, let's dive into this. How exactly does a hacker pull off this digital heist without a single username or password? Well, we can break the attack down into 4 precise phases. Think of this as our high-level roadmap. First up, they find the open door. Second, they tamper with the files. Third, they manipulate the external database connection. And finally, they take full control. Let's look at exactly how they move through each of these stages. It all starts here, at step 1, the open door. So Splunk uses an internal database tool to manage its data. To make things run super efficiently, the devs created a special communication channel called the Postgres sidecar. The fatal flaw here? This channel has a massive security gap because it lacks any authentication protocol whatsoever. It was probably designed assuming only internal, trusted systems would ever talk to it. But the reality? Anyone who can reach this endpoint over the network can just walk right in and start issuing commands. Once they're talking to the sidecar, we move right to step 2, file tampering. Because there are 0 security checks in place, the attacker can just start firing off malicious commands. They exploit the specific way the Splunk platform handles database backups. They trick the system, forcing it to write empty files or, honestly even worse, completely overwrite important, critical system files literally anywhere on the computer's hard drive. And this brilliantly illustrates the real turning point of the attack in step 3. Normally, Splunk connects to its own safe internal database to do its job. But here, the attacker modifies that connection command. Instead of looking inward, Splunk gets redirected to connect to an unsafe, external, hacker-controlled system. So, when Splunk initiates what it thinks is just a routine backup of a database, it's actually pulling a malicious payload from the hacker's system directly onto its own. Which brings us to the final, devastating step. The malicious file is now just sitting there on the Splunk server. The attacker simply tells Splunk to restore that database. That restore process forces Splunk to execute the hacker's commands. And here's the real kicker. Splunk natively runs with high administrative privileges. I mean, it needs those to do its job. So when it runs the hacker's code, it does so with those same top-level permissions, handing the attacker full, unrestrained control of the entire server. Just like that, the heist is complete. Section 3, securing your digital assets. Okay, let's take a breath and look at some proactive measures. I know the mechanics of that attack sound incredibly tense and frightening, but the solutions are entirely within your control. First up, the most crucial point to take away here is that the developers have already patched this Splunk enterprise vulnerability. So if you're running versions 10.0.7, 10.2.4, or 10.4, you are absolutely safe from this specific exploit. Furthermore, there's currently no evidence of threat actors actually exploiting this arbitrary code execution in the wild right now. But, as we always say, it never hurts to stay cautious and proactive. The source provides a fantastic checklist of proactive steps you really should be taking regardless. First, constantly update your setup to the newest versions. Second, restrict administrative privileges. Limit admin access to essential personnel only. If an attacker gets in, you really don't want every single account giving them the keys to the kingdom. Third, strengthen access controls using multi-factor authentication and strong, unique passwords to make credential bypass a lot harder. Fourth, educate your team to spot phishing and reduce human error. And finally, segment your network and back up your critical data. Let's look a little closer at that network segmentation piece, because the source specifically highlights it as a way to mitigate potential file operation vulnerabilities. The rule is super simple. Don't put all your eggs in one basket. By investing in multiple servers and keeping different parts of your network walled off from one another, a compromise in one area, like a Splunk server, doesn't automatically mean your entire enterprise is lost.
And of course, backups. They are your ultimate safety net when the absolute worst happens. But just having a backup isn't enough, right? You have to test these backups regularly and store them securely. If a hacker overwrites your system files, like we saw in step 2 of this exploit, a secure, tested backup is literally the only thing that ensures a rapid recovery without massive downtime. Seeing Splunk code execution happen without credentials is a stark reminder. It shows us that even the very tools we deploy to keep us safe can be turned against us. It proves that absolutely no platform is perfect. So I'm going to leave you with this final thought to help review your own security posture. Knowing that vulnerabilities can exist anywhere, how will you prioritize your cybersecurity today to keep potential attackers at bay tomorrow?